Hello. These are going to be notes on completing the square. So writing from standard form to vertex form for parabolas. In the past, this would be for worksheet 4, but it looks like we condensed worksheets this year. So this is actually going to be for worksheet 3 for e-learning. I'm just going to do 2 quick examples. You guys have learned how to complete the square before, but there's just a couple extra things in Algebra 2 that you're going to need to know. So the first step is to isolate just the parts that have an x. So I'm going to move this 5 over to the left side. So it looks like this, y minus 5. Actually, I'm not going to do the plus blank yet. I'll explain that in a second. Equals 2x squared plus 8x. Now, the next step, in Algebra 1, you would probably go right to completing the square. But what we need to do is factor out anything that might have an a value, but you just factor out the number. You do not want to factor out the x part, even though that there is a common factor there and they both have an x. You don't want to account for that. You're just going to pull out the a value of the parabola. So that's going to be 2. Parentheses, x squared plus 4, and now I am going to add in this blank spot. So this blank spot is because I am going to add a number into that side of the equation. And if I add a number to the right side of an equation, I must also add the same number to the left side of the equation. All right, so then I put a blank space on both sides. Okay. Next up is to complete the square. So complete the square, CTS, complete the square. To do that, rookie mistake. I caught it though. There does need to be an X here with the 4. Okay. Sorry about that, guys. But moving on, we do take that linear term in the parentheses, and what we're going to do is divide that number, you don't need the X, by 2. And then square it. So 2 squared is 4. This 4, this number, is the number you're going to add in to the equation. Now, before you add a 4 to both sides, that's actually wrong. On the right side, I am adding a 4 into the parentheses, but the true value of the number that I am adding to the right side is not 4. It's actually 4 times 2, okay, because that parentheses is actually being multiplied by 2. So the number I have to add to the left side of the equation is not 4, it's 4 times 2, which is 8, okay? So the actual value of the number I'm adding to the right side is 8. Now, I have a very professional way to remember to add 8 to the other side rather than 4, and I call it the bouncy bounce. We're going to take that 4, bounce it off the 2, and bounce it to the other side. Okay, the bouncy bounce, you can never forget it. 4 times 2 is 8. So if you ever hear me say, don't forget the bouncy bounce, that's what I'm talking about. I hope you guys are chuckling, but maybe not. All right, so -5 and 8, simplifying, is 3. Now, this is the next part that my Algebra 1 students are always like, I don't get what you did here, but you guys are Algebra 2. What I am going to do is actually factor this trinomial, okay? This trinomial factors 2x plus 2, x plus 2, which I hope you guys can agree I can rewrite like this, x plus 2 quantity squared. In these problems, the trinomial you're left with will always factor to a quantity squared. That's why it's called complete the square. What we're doing is we're adding a number in that will make that trinomial a perfect square trinomial. Okay, that's the whole point. So we skip this step typically, and we usually jump from that trinomial to the x plus 2 quantity squared. In Algebra 1, my kids are always like, wait, where did this 4 go? And I say, well, if I FOIL this back out, the 4 is there. Algebra 1 kids have a hard time understanding that, but hopefully you don't. So here's what I'm left with, okay? Left side is y plus 3, right side is 2 parentheses x plus 2 quantity squared. Next, we just get that y back by itself by subtracting that 3 back over. So here is my equation in vertex form. so special. You might be wondering, like, what's the point? I can easily just use the opposite b over 2a formula to find the vertex and graph from there, but we will be using this skill when we graph ellipses, circles, and hyperbolas, so that's why we're going over it now. And I'm just going to quickly do the same thing with example 4. I'm going to complete the square and then graph from there. Notice, though, that this is a horizontal parabola, but we do it the same way. So I get an x plus 6 equals negative y squared plus 4y. I am going to factor out that negative 1a value, which will give me a positive y squared minus 4y plus blank. On the left, I have the x plus 6 plus blank. All right, let's complete the square. Negative 4 divided by 2 is negative 2. Squared is positive 4. But don't forget the bouncy bounce. I'm not adding positive 4. I'm actually adding negative 4. All right, so now 6 and negative 4 is going to give me x plus 2 equals negative. Factor the trinomial, y minus 2, quantity squared. Here's a little trick. The number that you get before you square when you're doing the complete the square step is always matching to the number in the parentheses when you factor. Nice little tip for you. All right, we're done. Just move that 2 to the right side, and we get x equals negative, parentheses, y minus 2, quantity squared minus 2. That's my equation. So the vertex, the x value, remember the x value goes with the outside because it's horizontal, is going to be negative 2, and the y value will be positive 2. Change the sign. It is going to open left because there is a negative a value. A value is negative 1. 1 over 4 times a is negative 1/4, which is my p value. Reminder, this is a horizontal parabola, so the axis of symmetry is horizontal, so it's y equals 2, which is the y value of the vertex. Focus, h plus p, because we're horizontal. So when it's horizontal, we take h. I kind of remember that because horizontal starts with h. I'm just full of hot tips today, guys. H plus p is going to be negative 2, which is the h value, plus p, which is negative 1/4. So that is going to be negative 2 1/4, comma, positive 2. Directrix, h minus p. So that's negative 2 minus negative 1/4, which is actually plus. So that's going to be x equals, it's always the opposite of the axis, so it's x equals, what is it, negative 1 3/4. Sweet. Let's graph. Axis, y equals 2. That's here. This should be a dashed line. Then we're going to plot the vertex, which is negative 2, comma 2. Okay, and now this is going to open left. Let's plot the rest of our parabola. So left 1, A3, A5, A. So left 1, and then 1, 2, 3. Stop there. And the focus is at negative 2 1/4. Oops. And the directrix was at negative 1 3/4. Beautiful. That's the deal, you guys. All right, hope this helps.